Suppose you roll two dice. The first is red and the second is green. How many different rolls are possible? Well, the easiest way to do this problem is using the fundamental counting principle. If you do it that way, you're really just making two choices. You're choosing which number comes up on the red die, and you're choosing which number comes up on the green die. Since there's 6 numbers on each die, you have 6 choices, 1, 2, 3, 4, 5, or 6 for the first die, and you have 6 choices, 1, 2, 3, 4, 5, 6 for the second die, which means you have a total of 36 different rolls that are possible. Might also say that you're probably going to need it anyway, so another way you could have done it is to draw out the sample space for a 2 die roll problem the way I typically do, and then you can also count it that way. You really don't need to do that here because it's easy enough to use the fundamental counting principle. But if you do this way, the first one could be the red one could be a 1, the green one could be a 1, the red one could be a 1, the green one could be a 2, and so on. There's 36 possibilities. So either way, you really don't need to draw it out to answer that question. However, there are some other questions that usually follow along where you do need to write it out anyway. So it's not such a bad idea to write it out if you're going to use it again later. And you can see that that's the case because if you look at this problem, it says suppose you roll 2 dice. The first is red and the second is green, same as before. How many ways can you roll less than 5? Now this is where you can see the benefit to writing it out, the sample space out this way, because you can see that 4, 1 is 5, 3, 2 is 5, 2, 3 is 5, 1, 4 is 5. So if you want to stay less than 5, you have to roll one of these. If you count them, there are 1, 2, 3, 4, 5, 6. So there are 6 ways that you can roll less than a 5. And continuing on, this problem is simply testing you on basic calculation of a factorial. It says to evaluate the expression 16 factorial over 12 factorial. You could do the numerator and denominator separately if you wanted to. By definition, 16 factorial is 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. And 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you'll notice that everything from 12 on down divides out. So 16 factorial is really just 16 times 15 times 14 times 13. And if you multiply those 4 numbers together on your calculator, you'll get 43,680. Now I probably wouldn't do it this way because we have a calculator key that will do factorials. Remember that on the calculator, the Casio FX260 on the calculator, x factorial is the shift 3 key combination. So you do shift 3 and that'll give you x factorial. So what I could do then, if I'm going to do it on the calculator, is just put in 16, then do shift 3, that's the factorial, and then do divided by and put in 12 and do shift 3 again, which does the factorial of 12. And then to make it evaluate the division, you do equal. So if you do it that way, you will get the same answer. If you try that, you'll see that you also get 43,680. So that was just a little bit of practice on using your factorials. Let's do another. Okay, this problem says how many permutations of 9 things taken 3 at a time are there? That's just testing your basic knowledge of permutations. Remember, there's actually a formula for permutations, although given that you have a calculator that will do it, I'm not sure many of you actually want to do the calculation by hand, but if you did, that's the formula. Just throwing that out there. However, if you're only interested in that value, then I would suggest using the calculator and not doing it by hand. You do 9, and then you would do shift 1. Shift 1 is the permutation key combination. So shift 1 is for permutations. And then you put the bottom number from the permutation in there and you hit equal. If you do that, you will end up with an answer of 504. And if you do it using the formula, you will still get 504. Let's do one more. How about this one? How many combinations of 9 things taken 3 at a time are there? Well, again, now they're asking you a simple combination problem. The formula for combination is n factorial over the product of r factorial times n minus r factorial. But just as with the permutation, we have a calculator key combination that will do that, so I'm not sure anybody actually wants to do that by hand just for the fun of it. But the key combination for a combination is shift 3. So if we want to do by calculator, no, that's wrong. Shift 2 is the calculator, is the combination, I'm sorry. You would put in 9 and then you would do shift 2, and that's the key combination for a combination. And then you'd put in the 3 and you would hit equal. And if you do that, you're going to get 1,000. Let me go ahead and write this out. 1,680. Again, it's just testing if you know your combinations. Shift 1, shift 2, shift 3. Those are the ones that you need to know for your combinations and permutations and factorials. So just keep that in mind. Shift 1 is permutation, shift 2 is combination, shift 3 is factorial. If I'm not looking at the calculator, I have to really think about that too, but of course you're actually going to be looking at the calculator when you're doing these, so it shouldn't be such an issue.